All right, hello guys. We now move into question 4. Please know that all the questions on the 2021 January paper are a part of my playlist. It says all the questions are a part of it, but I've divided it into separate videos. All right. So we're now at question 4. And it says the function f is defined as, and of course, let us see how we read this. F is such that x maps on to 3 minus 2x. And next way of writing this so that people understand it better is simply to say that f of x is equal to 3 minus 2x. It means the same thing. All right, the diagram below shows the mapping diagram of f determining the value of a. All right, so x represents my input values. These are the values that I put inside of the function. F of x represents the values that I get out. Now, when you say f of x, is the same thing as saying y. So the question is, how do I find my a value? Now, my a value is actually an outcome. And to get that outcome, I would have to put in my -1 because -1 maps on to a. All right, so no problem there. So let me just say that f of x is equal to 3 minus 2x. So what we're saying is that when x is -1, what is a? So in other words, a is actually equal to f of -1, which is equal to 3 minus 2 times -1. All right. Now this is going to give me 3 minus -2, which is equal to is going to give me 5 because 3 minus -2 would give me a positive 5. So I know that a is 5 here. All right, so that part of the question would have been completed. Let's move down and see what happens. It says determine in their simplest form an expression for the function f of f inverse. Oh, the inverse of the function f inverse of x. So let me start by rewriting the function. We're going to start with the fact that f of x is equal to 3 minus 2x. All right, so f of x is equal to 3 minus 2x. All right, normally the first step is that we say let f of x, we call the function y because it's easier to manipulate that way. So we have y is equal to 3 minus 2x. Then we interchange x and y, right? We could have done it without interchanging, but we'll do it. So we're going to have x is equal to 3 minus 2y. Now, this is a matter of transposing to get back y, because once we get y, whatever y is equal to, that is the inverse of the function. All right, so what do? I can start by taking over the 3. So I could say x minus 3 is equal to -2y. We want y, so we can divide both sides by -2. All right, so y is equal to x minus 3 over -2. All right, and there are different ways we can manipulate this with a sign because I could divide through by a negative. I could divide everything by a negative to make it look better. So I would have y equal, if I divide x by a negative, it is positive, it's going to become -x. -3 becomes +3, and -2 becomes +2. So we could say, therefore, f inverse of x is equal to -x plus 3 over 2, or if you prefer to write 3 minus x over 2. They both mean the same thing. Okay? All right, let us take it down some more. Now, the second part of this now says b, the composite function f square of x. Now, let me explain what that means. That doesn't mean that you're going to multiply f of x by f of x. All right? What it really means, and let me rewrite it to show you what it means. F squared of x really means the same thing as saying f of x. So you're going to put f of x back into itself. All right? So what I'm going to have here is that I'm going to write the f of x function, and in the place of x, I'm going to put a bracket. Now, bear in mind that f of x, let me just put it back right here. F of x was equal to 3 minus 2x. So when you find f of x, the function f of x is going to replace your domain, which is x. So where I have x, I'm just going to put a big bracket there. So I'm going to have 3 minus 2, big bracket, and I'm going to put f of x inside of this bracket, which is 3 minus 2x. All right? Now, when we break this down, we have to do with the brackets first because of BIDMAS. So I'm going to have 3, -2 times 3 is -6. -2 times -2 is going to give me a +4, 4x. Now, 3 minus 6 is going to give me -3, and I'm going to have back my 4x. All right, so your concluding statement, therefore, f squared of x is equal to negative 3x, sorry, negative 3 plus 4x. All right. Or if it doesn't hurt to say 4x minus 3, it means the same thing. Or you could say 4x minus 3. All right. All right. Let's see what happens next. Now, this one now, part 3 says state the value of f inverse of negative 2. Now, I want you to understand what happens when you put an inverse in the original function. So when you find f of f inverse of x, right? Bear in mind that the inverse goes from the codomain back to the domain. The original functions goes from the domain to from the domain to the codomain. The inverse goes in reverse. All right. Now the inverse is a reflection in the line y equal x. So when I put the inverse function in the original function, what I get is a line of reflection, which is simply just equal to x, because these two functions are doing the opposite of each other. So f of x is from domain to codomain. F inverse is from codomain back to domain. So when you inverse a function, you plug the inverse function into the original function. It simply just gives you the output being equal to x. So with that deduction, we can say that f of f inverse of negative 2 is simply equal to negative 2. There's no need for working that out. And in fact, this is a general rule that you should know. All right, you can commit this to memory, that f of f inverse of x is equal to x. Also, it would follow through that f inverse of f of x is also equal to x, right? Very important rule there, very usable as well. Okay, let's see what the next question has in store. All right, we'll move on to part B of the question now. That says, using a ruler, draw the line x equal a half, y equal x, and x plus y equal 5 on the grid below. Now, x equal to a half. Let me start with that. So I'm going to get my straight line. Oh, in fact, let me pull up my ruler here. X equal a half means that you're going to find a half on the x-axis. All right. And of course, half is midway between 0 and 1. I know we can agree on that. All right, and you're going to draw a vertical line through that. So let me go right here. Let me get it as bold as possible so we can see it. All right, I'm just doing it bold so it's easier to see. All right, so let's see what happens. Okay, let me take off the ruler now so you can see it. So x equal a half is a vertical line going down through a half on the x-axis. And once you draw a line, the first thing you're going to do is to label it. So let me just put on that on the graph here. So this is the line x equal to a half. All right, y equal x. Now, we can strategically draw y equal x. What y equal x means is that whatever x is, y is the same value. Now, you just need two set of points to draw that. So if x is 1, y is going to be 1. So I can put a dot here. If x is 2, y is going to be 2. So that is what y equal x means. Whatever y is, x is the same. So we simply take our ruler and we'll line that up. Right? And we know it's going to pass through 0, 0 as well. So let me make sure we have all that lined up. All right. Not so perfect, but you get the idea of where we're coming from. So let me just get this line right here in. All right, so that's a line of y equal to x. And let me label it, say I don't forget it, y equal to x. Now the next line is x plus y equal to 5. Now I could transpose this equation, right? I could transpose it, but I don't have to transpose it, because what I can simply do is to just get a value for x and find what the y value I need to add to that x value to make 5. So for instance, let us say that x is 2. What would y have to be for it to be 5 when you add it? We know that 2 plus 3 is 5. So y would have to be 3. if x is 2, so you can put a dot there. What if we use 4? 4 plus what equal to 5? 4 plus 1 equal to 5. So if x is 4, y would have to be 1 because x and y must add to give you 5. All right, so now we have 2 points. So we just go back for the ruler and we'll line up these 2 points. Let me just see if I can get this lined up nicely. All right. Now let's see what happens now. I'm just going to draw my line here. All right, good. So let me take out the ruler now. So this line right here, I can label it x plus y equal to 5. So I would have had all my lines, and please remember that whenever you draw lines, you need to label them, all right? Let's go down and see what happens. On the grid, label as R the region where x is greater than or equal to a half. All right, so x is greater than or equal to a half. This is a line, x equal a half. This is the line. So if I were even going to shade the region there, I would have to shade to the right, all right, to the right of this line. Because it said greater than a half. So I'm looking at to the right, right? Let's look at the other one. The other line says that y is greater than or equal to x. Of course, that would mean that I would have to shade above the line. All right, so above is greater than, below is less than. So I would have a shade above this line at y equal to x. I would just be shading above, right? I'm not shading all of it because there's a region that we're looking for that should be common among all of them. So let us say we'd have shaded the region above here. All right, now the last equation, let me go back down and look, says that x plus y is less than or equal to 5. I said when it's less than, it means that we're talking about below the line. Now the line x plus y equal 5 was this line right here. So if we want x plus y is less than, we would have to shade below the line. So I'm thinking about below this line here. Below the line. Good. So notice that this is the region where everything would have been common. So what I'm simply going to do here is just to put a capital R. Big R. So this would have been the satisfactory region for all the inequalities that you have down there. Let me simply just go down a bit so you can see the inequalities. All right, so those are my 3 inequalities, and this is the region that would satisfy all 3 inequalities. We're thinking about linear programming here. This is a form of linear programming, although we never went into details like the normal real-life questions we have. But you just have to follow the instructions carefully. All right, guys, we'll move on to question 5, which looks to be somewhat statistic. Well, it is statistics. And it says 60 students took an algebra test, which comprised of 15 multiple choice questions. The number of correct answers that each student obtained is recorded in the table below. All right, good. So you have one column, which is the left column, is the number of correct answers. And on the right, you have the number of students who got that amount of answers correct. So the first question says, using a table, the number of students who had exactly 13 correct answers. So all you have to do is look in the number of correct answers column, look for 13, and you see 11. So 11 students had exactly 13 correct answers. So that part is straightforward. All right, no worries there. Let's move on to the next part, which is part 2, the modal number of correct answers. All right, modal score is a score with the highest frequency. The frequency column, of course, is the column that represents the number of students. So I'm just going to put a little f here, which means frequency. So the modal number of correct answers, I'm looking for the highest value in the frequency column, which is the number of students, which is in this case 14. So what this is saying is that 14 students got 9 correct answers. So that is the most occurring value. 9 correct answers is the most occurring, right? The 14 is just telling you what the frequency is. So the mode is not the 14. The 14 tells you how many times the 9 occurs. So the 9 is the modal correct number of correct answers. So this would be 9 here. All right, let's see what happens next. The next one is the median. Of course, the median is the middle value. Now, in a case like this, where we have really ungrouped data, the median value, there's a little formula that we use to find the median value. The median value is also called the second quartile, all right? Which we call it Q 2. All right, there's a position that Q2 falls in, position of Q2. The position of Q2 is equal to n plus 1 over 2. N is the number of squares you have, or the total frequency, which the question told you was 60. So it would be 60 plus 1 over 2, which is equal to 30.5. So what it means, let me explain what this 30.5 means. 30.5 is between 30th and the 31st value. So what it means is that I'm going to add the frequency until I get to the 30th and the 31st value. Cool? Now, whatever, if there are two different values, I'm going to add them and average them. All right? If there's the same value, there's no need to average it. All right, so let's start adding. All right, remember we're looking for the 30th value and the 32nd. Now, 14 plus 6 is 20, plus 2 is 22, plus 6 is 28. All right, plus 2 is 30. So the 30th value is 12. All right. Now, the 31st value would naturally be the next value, which is 13. So to get the median score, I'm going to have to add the 12 and the 13 and divide it by 2, which is going to be 12.5. All right. So the median score, or the median number of correct answers, is equal to 12.5. So I'm going to just put that in there. Even though 12.5 doesn't fall within the scoring value. So sometimes you'll find out that when you find the mean, or sometimes you end up finding the mode. Well, not in a case like this. The mode will naturally be a part of it because this is on group data. But sometimes you find out that the median score and probably even the average is not necessarily a value that you have inside of the table. All right, because these are measures of central tendencies where the central value tends to fall. All right, so you don't necessarily have to get a value inside of the table. But this is how we normally go about finding the median in a case like this where you have on-group data. All right, let's go down. So part 4 of the question says the probability that a student selected at random had at least 12 correct answers. All right, I'm just showing this on P stands for probability. So the probability of at least 12 correct answers. Now we have to know what at least means. All right, at least means what? Greater than or equal to 12. So the number of correct answers is greater than or equal to 12. All right, so let us go up to the table and see what the table is saying to us. So remember, we're looking for 12 or more. The frequency will tell us this. So we're looking for 12 in the frequency column, which of course is right here. It says 12 or more correct answers. All right, so how many persons got 12 or more correct answers, in other words? So this is 2 here, plus 11, that's 13, plus 9, that is 23, plus 10, that's 33. All right. So let me just go back down, and that would be out of 60 because we're talking about probability. All right, so your sample space is 60, total number of persons. So this would be equal to, let me just put this in, 33 over 60. Now, can I break this down? When it comes to probability, we normally break it down as far as possible. Now, 3 can go into both of them. Now, 3 into 33, you know, is 11. 3 into 60 is 20. So you're going to have 11 over 20. And that would be your probability. All right. So that's the end of the first part of question 5. We're now going to move to the second part. All right, we'll move into question B. It says a group of students wrote a physics examination. Each of the students had achieved a grade 1, 2, 3, or 4. The pie chart below shows the result. And by now, you all know that the passing grades are 1, 2, 3. All right, and more so you should aim to get 1. All right, it says 39 students achieve a grade of 3, determining the total number of students who wrote the examination. All right, now, what do we know about a pie chart? We know that for a pie chart, the total angles, because we use angles and quantities here, the sum of the angles is equal to 360 degrees, all right? So 360 degrees would represent the total amount. We're going to call it X, all right? Because The size of the angle reflects the number of students you have. So they are synonymous. So in other words, you can say 360 will represent the total amount. We have 117 degrees here, which is representing 39 students. Good. So we have a scenario now where we can use our knowledge of cross multiplication to work out the value of x, which is the total number of students. How do I do that? All right, let's go. We say 360, so the total 117 is x. So we can cross multiply here. So I'm going to have 117x is equal to 360 multiplied by 39. And of course, no better thing to do this than your calculator. So I'm just going to bring that up. All right. And while we bring up, all right, here it is. So I'm going to put 360 multiplied by 39. And that's 14,040. So I'm going to have 117x is equal to 14,040. We want x, so we're going to have to divide both sides by 117. All right, over 117. So x is equal to, let me pull up back my calculator and see what my calculator is saying. All right, so divided by 117, that's 120. So this is equal to 120. And you can write a statement. So therefore, there are 120 students in all, right? Just put that down there. All right, let us see what the next part of the question has to offer. Now, guys, what I've done is that I've summarized the details from the pie chart down here, so we don't have to go back. So the total is 120. The amount of persons who got grade 3 was 39, and the angle was 117 degrees. All right, let's move on. Now, this question, part 2, says the ratio of the number of students who achieve grade 1 to 2 to 4 is 2 to 4 to 3. A student passes the examination if he achieves a grade of 1, 2, or 3. How many students pass the examination? Okay, first of all, we already know how many persons got grade 3. All right, we know that 39 persons got that. So that's out of the ratio, which means that I'm going to have to find the total amount of persons who represents grade 1, 2, and 4. So it would be 120 minus 39, which is going to give me 81. All right, so we have 81 persons to divide among grade 1, 2, and 4. And we have the ratio. Now, the person would pass out of this lot. We know that the persons who get grade 3 pass, and we know how many persons that is already. That's 39. But out of this total ratio, the number of persons who get grade 1 and 2 would pass. So let us add up the ratio. 2 plus 4 plus 3. That's going to give me 4 and 3 is 7 plus 2, 9. So the total here is equal to 9. Now the passing mark would be the persons who get either 1 or 2 from the slot. So the total ratio there would have been 4 plus 2, which is 6. So 6 out of 9. Why 6 out of 9? Because if they get 2 or 1, they would have passed. All right, and the sum of the ratio here is 9. So it will be 6 out of 9 multiplied by 81. All right. And we can simply use our knowledge of fraction here and break this down. So 9 into 9 is 1. 9 into 81 is 9. 6 times 54. 9. All right. How many persons pass the examination? All right. So we know that it would have been 54 here. But we also know that the number of persons who got grade 3 was 39. So it would have been 54 plus 39. This would reflect the number of persons who would have passed the exam. All right. So that is going to give me 93. So 93 persons pass. Let me explain that again. We already know how many persons got 3. The persons who got 3 would have passed. That would be 39. They gave us a ratio of the persons who got 1 to 2 to 4. If you get 4, you fail. So the passing grades out of this ratio would be 1 and 2. Which we add the ratios for those, which is 2 plus 4 would give me 6. The sum of the ratio is 9. So that sum represents the total amount of persons who got 1, 2, and 4. But the persons who pass out of that lot would have been 6 out of 9. And the sum remaining, if we take out the amount of persons who got 3, would have been 81. And so we got 54. So this 54 represents the number of persons who got 1 and 2. But then we have to go back now and remember that 39 persons got 3, and they would have passed as well. All right, so we add that 39 to 54, and we say that 93 persons would have passed. Okay, let's go down a bit more. Determine the value of the size of the angle representing grade 1 in the pie chart. Okay, not a problem. Now, we can easily find the number of persons who got grade 1 from a ratio that was 2. All right, so it would have been 2 out of 9 times your 81. So let me just write that out here. So it would have been 2 out of 9 multiplied by 81. All right, 9 to that goes, so that is going to give me 18. Now, what we want is the size of the angle, which is not going to be difficult because we know that the total thing measures 360 degrees. All right, so this 18, let me just get the second here. This is the 18 out of the total. So it would have been 18. In all, we have 120 multiplied by 360. Okay, let's start by breaking down the zeros. 12 into 12 is 1. 12 into 36 is 3. All right. Now 3 times 18 would give me 54. So the angle is equal to 54 degrees. All right, and that's it. So we just have to remember the total angle is 360. So everything is a ratio of 360. All right. All right.